Assalamualaikum and good day everyone. In this video, we are going to discuss on the properties of determinants. So there are 6 properties of determinants. So let us start with the first one. Okay, for the first properties, if matrix B is obtained by multiplying a single row or column of matrix A by a scalar K, then the determinant of matrix B is equals to K determinant of A. So as you can see here, you have matrix A and matrix B is obtained, or matrix B is formed by multiplying the second row of matrix A with a scalar K, while the first row and the third row remain unchanged. Okay, so therefore, by using the properties, you can get the determinant of matrix B by using K determinant of A. If let's say you have matrix A is equals to 1, 2, 3, 0, 1, 2, 4, 1, 3. And you know that the determinant of this matrix A is equals to 5. And you have matrix B such that matrix B is equals to 1, 2, 3, 0, 1, 2, 8, 2, 6. And you were asked to find the determinant of matrix B. If you compare matrix A and matrix B, you can see the first two rows are the same, except for the third row of matrix B. The third row is obtained by multiplying each element in the third row of matrix A by a scalar K. So in this case, your K is equals to 2. So 4 multiplied by 2, so you have 8 here. 1 multiplied by 2, you have 2. 3 multiplied by 2, you have 6. Okay. So by using properties, you can simply get the determinant of B, which is, so determinant of B is equals to K determinant of A. Since your K is equals to 2, the determinant of A is equals to 5. So therefore, you will have the determinant of B is equals to 10. So in this case, the third row is multiplied by a scalar K to obtain the new element for the third row of matrix B. For the second properties, if every element in matrix A is multiplied by a scalar K, then the determinant of Ka, or determinant of a new matrix, is equals to K to the power of n determinant of A, where n is the order of the matrix, or n is the size of the matrix. So what is the difference between the first properties with the second properties? So in the first properties here, only a single row or a single column is multiplied by a scalar K. But for the second properties, the new matrix is obtained by multiplying each element in matrix A with scalar K. Okay, so let's consider, let's say you have matrix A is equals to 1, 2, 3, 0, 1, 2, 4, 1, 3. And you know that the determinant of matrix A is equals to 5. And you have matrix B, which is equals to 2, 4, 6, 0, 2, 4, 8, 2, 6. So you were asked to find the determinant of matrix B. Okay, so if you compare matrix A and matrix B, so matrix B is obtained when each element in matrix A is multiplied by a scalar K such that K here is equals to 2. Okay, so 1 multiplied by 2, you have 2. 2 multiplied by 2, you have 4. 3 multiplied by 2, you have 6. And so on until the last one, 3 multiplied by 2, you have 6. Okay, so therefore, by using these properties, the second properties here, you can simply get the determinant of B, which is equals to K to the power of N, determinant of A. So what is your N here? Since this is 3 by 3 matrix, so therefore your N is equals to 3. Okay, so the determinant of B is equals to 2 to the power of 3 multiplied with 5. So you will have 40. Okay, now let's take a look at another example here. How these two determinants are related. Okay, the symbol here refer as a determinant. Okay, let's say I consider the first one as a matrix A. Okay, so I have 5, 3, 1, 0, 2, negative 4, 3, 3, 0. And matrix B is equals to negative 15, negative 9, negative 3, 0, negative 6, 12, negative 9, negative 9, 0. Okay, so we can say that matrix B is obtained by multiplying each element in matrix A by scalar K, where in this case your K is equals to negative 3. So you will have 5 multiplied with negative 3, you have negative 15. 3 multiplied by negative 3 is equals to negative 9. And so on and so forth until the last one, 0 multiplied with negative 3 will be 0. Okay, so what can you say about the determinant of matrix B and matrix A? So the determinant of matrix B is equals to K to the power of N, determinant of matrix A. Okay, so this is how these two determinants are related. The third properties, if matrix B is obtained by interchange or switching 2 rows or 2 columns of matrix A, then the determinant of B is equals to negative determinant of A. So if you compare these two matrices here, we can say that matrix B is obtained by switching the first 2 rows. Okay, so this one here, so for matrix B we will switch. Okay, so therefore for you to get the determinant of matrix B is equals to negative determinants of matrix A. So let's say you have a matrix equals to 1, 2, 3, 0, 1, 2, 4, 1, 3. And you know that the determinant of this matrix is equals to 5. And you have a matrix B here such that matrix B is equals to 3, 2, 3, 2, 1, 1, 1, 0, 4. So what is the determinant of matrix B? Okay, so if you compare these two matrices, you can see that matrix B is formed by interchange 2 columns of matrix A while another column remain unchanged. Okay, so as you can see here, we will interchange column 1 with column 3. Okay. So column 2 remain unchanged. What is the determinant of matrix B? So you can simply get the determinant of matrix B is equals to negative determinant of matrix A, which is equals to negative 5. The next properties, addition or subtraction, a multiple of one row to another row, leave the determinant unchanged. So here matrix B is obtained with matrix B is obtained such that the second row and the third row is the same as the matrix A. But for the first row here, the first row of matrix B is obtained by an operation which involves row 1 and row 2. So it can be row 1 and row 2, row 1 and row 3, but you have to depends on what you have for matrix B. Okay, so in this case, if you compare, so clearly the first row is not the same as the first row in matrix A. So the first row is obtained, the first row of matrix B is obtained by an operation which involves the first row and the second row of matrix A. Let's say we have matrix A is equals to, and we know that the determinant of matrix A is equals to 5. Okay. And matrix B is given by 1, 4, 7, 0, 1, 2, 4, 1, 3. And you were asked to find the determinant of matrix B. So if you compare, only the first row of matrix A, element in the first row of matrix A is not equals to element in the first row of matrix B, while for the second row and the third row remain unchanged. So how matrix B can have this value 1, 4 and 7? So by using an operation R1 plus 2R2. So in this example, they are using this operation. So different example might use different operation. Okay, it depends on what you have on your matrix B, and you need to compare with the matrix A. Okay, so how can I obtain this operation? Okay, first, clearly the row that is changed is row 1. Okay, row 1. So R1 plus 2R2. So let's say for the first one here, R1 is equals to 1 plus 2. So R2 here. So this one we refer as row 1 and this is as row 2. Okay, an operation involve these two row will result a new row for matrix B. Okay, so 1 plus 2 multiply with 0 is equals to 1. The next one, 2 plus 2 multiplied by 1 is equals to 4. And the last one, 3 plus 2 multiplied by 2 is equals to 7. So that's how 1, 4, 7 are obtained. Okay, so by using these properties, the determinant of B remain unchanged. Okay, because we just change one row, the second and the third row remain unchanged, and one row is produced based on the operation of based on the operation on two rows of matrix A. Okay, so therefore the determinant of B is equals to determinant of A, which is equals to 5. Okay, it can be any rows or any columns. Okay, you have to depends on what you have on matrix B and compare with matrix A. The next one, if matrix A and matrix B are two square matrices such that AB exists, then the determinant of AB is equals to determinant of A multiplied with determinant of B. Okay, so consider this matrix here. You have A is equals, the determinant of A is equals to 5. The determinant of matrix B is equals to 10. So if you are asked to find the determinant of AB, you don't need to calculate A multiplied by B, then get the determinant of this one. You can simply get the determinant by using these properties. So this property state that if you want to find the determinant of AB, this one is equals to determinant of A multiplied with determinant of B. So the answer is 50. Okay, take a look at this example here. They are using these properties, but the way the question is asked is differently. So we are going to discuss this one. You are given a matrix A, and you have an unknown here, and this is matrix B. And you have a clue that the determinant of AB is equals to negative 190. So find the value of the unknown. So by using these properties, we know that determinant of AB is equals to determinant of A multiplied by determinant of B. Okay, so if you compare matrix A and matrix B, you can find the determinant of matrix B, since every element in matrix B is a value. Okay, but for matrix A, you have an unknown here, so you cannot find the determinant of matrix A. Okay, so let us start by finding the determinant of matrix B first. Okay, so by expanding along the first row, the determinant of B is equals to, so the first element is 0. So 0 multiplied with any value will give you 0. So I will just keep, since this one will give the answer 0. So we start with the second one, which is 1. So the value is 1 here, and the symbol is negative. So we will cancel row 1, column 2. So you will have negative 2, 2, 1, 0. Plus, so the last value is 3. The symbol is plus. So cancel the first row and the third column. So we will have negative 2, 5, 1, 1. So this one is equals to negative 2 plus 3, negative 2 minus 5. So this one is equals to negative 19. So by using the above properties, so determinant of AB is equals to determinant of A multiplied with determinant of B, such that this AB is equals to negative 190 is equals to determinant of A multiplied with negative 19. So we can get the determinant of A is equals to 10. So we can use this one to find the value of the unknown X. The matrix A is given by, okay, so I'm using the third row. I will expand the third row since I have 0 here. So I can just proceed with the last value. Is equals to 1. So the symbol here is plus. Okay. So plus, so what will you have? Cancel row 3, column 3. So you will have x, -1, -2, x, which is equals to 10. So this one you will have x squared minus 2 is equals to 10. X squared is equals to 12. So therefore your x is equals to plus minus square root 12. Okay, so if you replace the value of x is equals to 12, if you substitute x is equals to square root of 12 here and here, you will get the determinant is equals to 10. Or if you substitute x is equals to negative square root of 12, negative square root of 12, you also get 10. So the last properties here. If two rows of two columns of a matrix are equal, then the determinant of the matrix is 0. Okay, so let's consider the first matrix here. As you can see, the first row is equals to the second row. So the determinant of this matrix is equals to 0. Or for the second one here, the first column is equals to the third column. So again here, the determinant is equals to 0. So let's try this example here. You were asked to find the value of x and y such that the determinant of this matrix is equals to 0. So this is the hint here. Okay, we know that if the determinant of the matrix is equals to 0, so there must be two rows or two columns which are equal. Okay, so if you compare, you can see that the first row with the third row. So therefore, we will have x is equals to 4, y is equals to 2. So that's all for the properties of determinants. So basically, these properties is applied to find the determinant without doing a long calculation. Okay, so if you don't remember these properties, you can still get the determinants of the matrix by using long calculation. Okay, so I shall see you in my next video for more discussion. Thank you. Assalamualaikum.